Okay, we're in section 5 of the notes, examples. We just presented the lecture to you. Hopefully that made sense to you. Hopefully it's a recollection of what you've done in Math 121. Now, of course, we're in 122. We're trying to review these so we can move forward into the content of Math 122. All right, so I'll do some examples. And then after I do the examples, there'll be a chance for you to try with the homework. You want to do that. So let me switch screens. All right, so let's take a look at this first problem here. Number 1, they do say find the volume of the solid obtained by rotating the region. There's a picture. I don't mind you looking at a picture, but you should generate your own pictures. And they say bounded by y equals x cubed, y equals 8, x equals 0 about the y-axis. So the first thing I would do is, certainly you're more than welcome to look at the picture on the next page, but you really should be able to do this on your own. And I'm going to put down y equals x cubed, sort of looks like this over here. Yeah, I'm not saying it's a terribly accurate picture, but it's enough for me. And y equals 8 looks like this over here. And again, this is y equals x cubed. And then they say x equals 0. That looks like this over here. So yeah, I know the region now. This is the region. All right, that's the region they're talking about that. All right. So I'm going to put the points down for you. And certainly this is the origin. It's 0, 0. This is the point over here. It looks like the y is 8, right? So what would the x have to be? The x would have to be 2, because 2 cubed is 8. And what's over there? That's pretty simple. That's going to be 0 for x, 8 for y. All right, now what are they going to do? They're going to rotate this region about the y-axis. So it's being rotated like this. So what I'd like to do is I like to visualize. Basically, I'm actually visualizing a rectangle. And when this rectangle gets rotated, it's going to look like a disc. That's what it's going to look like. So what I'm going to do is I'm going to try to add the discs together, their volumes, along the y-axis. Let me write my integration down now. So I'm going to start, it starts at 0, goes up to 8. The differential is dy. This is dy. Then I got to do the surface area. What's surface area going to be? Pi r squared. The r is going to be difficult for some students. I want to point out why. It's actually just x. But what's x? Well, I don't know what x is, but I know that y is equal to x cubed. So that means x is equal to y to the 1/3. Let me put that in for you. I'm going to try to do my integration now. Pi 0 to 8. We'll look at the key later. That's y to the 2/3 dy. Pi, I increase it by 1, so that's y to the 5/3. I divide by 5/3 or multiply by 3/5. 0 to 8. I'm hoping it's going to be easy to do. 3 pi over 5. I want to point out that y to the 3/5 is going to be actually 1 2/3. So it's going to be 8 cube root of 8 squared minus, well, the lower limit's 0, so that's easy. That's 0, right? I got to do that arithmetic. No, I don't need a machine to do that. That doesn't mean I can't make an error, by the way. So it's going to be times 8, and the cube root of 8 is 2, and 2 squared is 4. All right, let me do that arithmetic over here. Let's see what you're going to get. That's going to be 32, 96 pi over 5. Let's take a look, see how we did. Wow, we got it. All right. So again, I'm not saying it's a difficult question. It's a question you should be able to do on your own. It's going to take practice, though. I'll tell you that. All right. Give me a little picture. By the way, these pictures, I lifted them out of a book. Let's do this one over here. They give you pictures, just, but I think I probably don't need a picture to do it. Let me just see if I can handle it. So it says, y equals x, put this on the side. That looks like this. And the other curve is, x squared. And so the y equals x squared looks sort of like this over here. And I know what this point of intersection would be. Pretty simple, a really simple object, 1, 1. And this point over here is 0, 0. And I see the region, and this would be the region. Right, I'm clearly seeing a region. Where they say that region enclosed by those curves is rotated about the x-axis. It's the x-axis here. All right, again, I'm going to visualize, my understanding of a rectangle, which might seem strange to some students, like this over here. But what I have is I have a big object, and I want to remove something from it. So this empty space needs to be removed. So I'm going to write the integrations down, and I'm moving along the x-axis now from 0 to 1 dx pi r squared. But what's r? Well, the big object here, I want to point this out to you, the big object, this thing over here, it's just going to be x. I'll put that down for you, and we'll do that later. Minus, I got to remove something, and I'm removing this region here, right? It's a disk, I'm removing it. So let's put that down for you. Minus 0 to 1 pi r squared dx. I got to figure that out. And what's over here? Well, y equals x squared. So we go over here, x squared. All right, I got to do my work. And I'll write it down for you. Pi x, let's see, it's square, right? So it's cubed over 3, 0 to 1, minus pi, that's x4, so it's going to be x5 over 5, 0 to 1. Looks fairly simple to do, by the way. What do you get here? Pi over 3, minus 0, I'm not going to put that down, minus pi over 5, minus 0, I'm not going to put that down. Common number is 15, and you can get 5 pi minus 3 pi, which is 2 pi. Pretty simple arithmetic. Do I make mistakes? All the time. That's why we like to give you a K. All right. Now, I want to point out, as soon as when am I going to get a chance to try? We can't say this enough to you. You need to start trying. You really do. Where are you going to try? Try to do the homework. See what you can do. I'm also going to post a video of me doing your homework. I try it too. All right. You want to try it though. It isn't what I do. It's what you do that's going to make successful. All right. Good luck. And if you need help, please feel free to stop by during office hours, and we'll be more than happy to help you.